one new concept that I want to introduce is the idea of masking, since we are already sitting at attention, right? So there are two use cases that we will see, or two comparisons of two different transformers that we will see. One is the decoder only transformer has only a decoder stack of our transformer. So this is, let's say, the decoder stack of the transformer, right? And let me show you a flow chart that only has the decoder. Yes. So we have an input. We have seen that particular layer. Then this sublayer we have explored, which is multi-head attention, right? Yeah. So we have explored this sublayer, which is multi-head attention. We are yet to explore this particular sublayer. Let's call it add and nor, right? Now here something happens. I want to show you that. Okay. When we are dealing with the GPT family, right? So this does not stand true in case of attention is all you need. When we are dealing with GPT family, we have an idea of masking at attention level, right? The decoder only models that belong to the GPT family, they do something like this. Let's say this is the attention matrix. They mask all the future tokens. Now, what do I mean by future tokens? So for example, I'm standing at here, a random point on. What comes before on, sat, cat, and the? So when I'm standing at on, I will only be able to see the tokens that are, the current token and the previous tokens. I will not be able to see the future tokens, right? So all the tokens that come after token I, right? Token I cannot see I plus 1, I plus 2, I plus 3, I plus 4, right? It can only see I and I minus 1 and so on, right? So we mask all the future tokens. By masking, I simply mean that we blur them, right? We make them dead. We mark them as negative infinity, so that when softmax captures it, approaches to 0, right? So we don't want to deal with these values. So this is known as masking. This is also known as causal masking or look ahead masking. So this is only used in decoder only family or decoder only transformers, or the GPT family leverages this, right? So there are two phases of every network, no matter whether it is a transformer or a neural network. So training phase and inference phase. During training phase, we are doing this particular operation of masking, right? When we are training the neural network, we are hiding the upper triangular matrix, right? In case of attention, is all you need. The encoder decoder, the encoder stack will see everything. The decoder stack will not see this, right? So what we are trying to do is, why are we trying to do this? We have seen what we are trying to do. We have seen, now we want to know why we are trying to do. We want to prevent the model from cheating during training phase, right? Because at inference phase, when I'm typing something in chat GPT, right, or when I'm interacting at inference time, at querying time with GPT models, they have to predict the future. I don't know the future, right? So at training time also, I'm enforcing them the idea that you don't know the future, you have to predict the future, right? You have to learn how to model complete sentences. You have to learn how do I predict the next token, right? You have to predict on based on what you have already seen before, right? You cannot go unit bidirectional. You can only go one direction, left to right. You cannot look ahead. You can only look backwards, right? Because the probability is modeled in such a way that you have to compute the probability of token t given token 1, 2, 3, 4, so on till t minus 1, right? That's why this is the idea that we introduce, which is also known as masking, right? So we use it in all decoder family, all the GPT family, the decoder only transformers, right? So this helps us create an autoregressive model that can predict the next word using, only the available words from 1 to n minus 1 or 1 to t minus 1. That's it. This is the idea of causal masking, and we do it at attention level. This is the attention matrix, right? So yeah, thank you.